fake quiz, and we're going to go to number 14. Ah, yes. Okay, optimization. Came back. So number 14, it asks us to find the minimum distance from the origin to the curve. Now, just thinking in terms of normal calculus, how do I find a minimum of a function? The derivative, what do we do with that derivative? Good. We take our derivative, set it equal to 0, and then for a minimum, what needs to happen? Negative positive. Okay. So this is how we normally do minimums. And so we're going to do the same thing here. Now we have to figure out what our equation is. It says minimum distance. So I'm optimizing my distance. I want to find the minimum distance. So distance is what I'm taking the derivative of. Now my distance formula, you may have not believed me when I told you that you needed to know this. Your distance formula, dig back to your geometry years. x2 minus x1 quantity squared plus y2 minus y1 quantity squared all squared. Now it says the distance from the origin to the curve. So my origin is the point 0, 0. And my point is going to be on the curve. I don't know where that is located, but I know that whatever x value, the y value will be e to the x. So that's just my function. Those are the 2 points we use with our distance formula. And that is how we arrive at this. Questions on getting to there? Now you have a few different options as to how you go about taking your derivative and setting it equal to 0. On the key here we see that essentially they squared both sides and then relabeled this as q. Q just meaning the quantity that they want to minimize. The reason why you can do this is because if you think about it, let's say this is our starting point. And here's point A, here's point B. If I look at the distance from A and B, isn't my minimum going to be at the same location as if I looked at the distance squared? If I looked at the distance squared to A and the distance squared to B, isn't the minimum distance squared going to be at the same spot as my minimum distance? Do you guys agree with that? Whether I'm looking at just the distance or the distance squared, the minimum is going to occur at the same spot. If this is the smallest distance, then the smallest distance squared is still going to be where the smallest distance was. So that's what the key took the approach of. They said, okay, well, I want to minimize distance. That's going to be the same as minimizing my distance squared. I do not know what's happening over there. Isn't this the class that's always coming? Yeah. Alright. Now the other approach you can take with this is taking your derivative just like normal. So let me erase this. Okay, so going from here, I can take my derivative like normal. So the derivative of distance, so we have 1/2, inside stays the same. Reduce your power by 1, multiply by derivative of the inside. And this is the same thing. If we were to rewrite it out, see, we'd have 2 in the denominator. We'd have that square root of x squared plus root of x, and this is on part. Alright, do we agree that that would be my derivative? Are we okay with that? What happened there? Questions? Okay. Now, again, to find the minimum, we want to take our derivative and set it equal to 0. So if I take this and set it equal to 0, in a fraction, what do I need to be 0 in order for the whole thing to be 0? I heard one person that said it correctly. How do I make this whole fraction 0? What needs to be 0? Just the top. I just need for the top to be 0 in order for the whole fraction to be 0. Notice that we achieve the same thing, regardless of which method we use. Okay, so you can take the derivative like normal, you're going to arrive at the same thing. Now, a third way you could approach this So my distance is square root of x squared plus e to the 2x. If I square both sides, then I get my distance squared. It's x squared plus e to the 2x. Now when I take my derivative would be 2d, and then the derivative would be d prime, equals 2x plus 2e to the 2x. Once again, we want to take our derivative and set it equal to 0. So this represents my derivative. If I take this and set it equal to 0, putting in 0 for this, what's 2d times 0? 0. So again, I'm going to achieve the exact same thing. We're trying to find my minimum. So regardless of which method you use, you'll arrive at the same final thing, the same final equation that we're trying to get this equal to 0. Okay, questions so far on this one?
For the way you did it in the green pen, why did you only set it the derivative equal to 0 as opposed to setting it equal to 0 and then 1 over 0?
Because we want to consider both equal to 0 and undefined. Now, when I take a look at this down here, though, can I ever get x squared to be 0? I can get that to be 0, but e to the 2x will always be a positive value. So I end up never being able to get the denominator equal to 0. So yeah, we do want to consider both 0 and undefined. For this one, undefined didn't make a difference for us. Good question. Other questions so far? Okay. So now we're at this point. I don't know how to solve this. You don't know how to solve this, but it's a calculator problem. So use your calculator. You can do 0 or you can do intersect, and that's how we get our x value from there. Now they wanted the distance, so you take the x value and substitute it back in. Once again, do not round until the end. So store as much as you can in for x and then calculate. All right, questions with the final piece of homework. Let's go up to 3. All right, so number 3 here, we have secant squared x over tangent x. We do not have a quotient rule for integration, so most likely that's what we need to do. Now, if I let u be secant x, what's the derivative of secant? Secant tangent. Good. The derivative of secant is secant tangent. If I were to try to let u be secant, the derivative would be secant tangent. That does not perfectly take care of what we have. If we let our derivative be if we let u be secant squared, then we'd have 2 secant tangent, which is even more complicated. That is why it's advantageous for us to let u be that denominator. A lot of times when you have a fraction, u will be the denominator. Not always, but sometimes it is beneficial to try that. Sometimes it's better to try the top, but I would try bottom first. So letting u be our denominator of tangent x, the derivative tangent is secant squared, so that takes care of that piece. But don't forget, you have to change these bounds. So we get our new bounds. And then now we have 1 over u, which we know the inside derivative would be natural log of the absolute value of u. And again, keeping those new bounds. We have natural log of the square root of 3 minus natural log of 1. Natural log of 1 is just 0, so we have natural log of the square root of 3. This could have also been written as 1/2 natural log of 3, so just keep that in mind. Different options. Questions with that one? So we could write this as natural log of 3 to the 1/2, because square root and then the power comes out. Yeah, with logs, guys, they love using those properties. Definitely on multiple choice.
Wait, Ms. Garner?
Yes?
Wait, why is the absolute value disappear? Because you're plugging the 3 into it?
So absolute value of square root of 3 is just square root of 3. Alright, and then let's go ahead and go to 9 and then 10. Ooh, point of inflection, yes. I just love that these justifications continue to stay with us throughout the whole year. It's like it's important or something. Alright, so number 9. They want to know the coordinates of the point of inflection. Think back to your justifications. What do I need for my point of inflection? Second derivative, which was just a blast for this problem. So we need our second derivative. And once we get our second derivative, what do we have to do with that? Yeah, we're looking for a change in sign. So set equal to 0 and undefined and look for change in signs. Okay. Now with this first derivative, we have to use product rule. And then we, for our second derivative, end up needing to use quotient rule for this piece. So it was a little crazy. But in simplifying it down, we get down to our second derivative is this. Okay. Now again, we need to look at both when it is equal to 0 and when it is undefined. So we need to take the top set equal to 0, that tells me my function's equal to 0. And undefined is taking the bottom and saying equal to 0. Now, sorry, that's not part of it. Taking the bottom and saying equal to 0. Now when I have x squared plus 1, 20 squared equals 0. You could stop right here and be like, wait, that's always positive, we're never going to equal 0. But if you miss that and you try to solve, you get x squared plus 1 equals 0. X squared equals negative 1. And x equals plus or minus I. We do not deal with imaginary numbers in AB Calc. So we are not going to work with those. We are in the real number system for AB Calc. Alright, so from here we get one single possible point of inflection. And that's at 1. Now we should test this on the number line. When we do, we find out it is indeed a point of inflection. But they want the coordinates, so we know our x value, which means we can eliminate, oh, look at that. We can eliminate 3 of our choices. And then once I know my x value, again, I want to know where this occurs on the original graph. It's the point of inflection on the original graph. Once I know x, how do I find y? Put it back into our original. So that's what's happening over here. So taking 1 and putting it in, and then you need to know your unit circle for that. And we get for our y value, 2 times pi over 4, which is pi over 2. All right, questions with that? Bart, are you still like back there? Ooh, I was afraid of that. We put it back into our original function because the point of inflection is on the original function. So I know where it occurs for x. What's the line of those? Is that what you always look like when you wake up? All right. So now let's take a look at number 10. I feel like number 10 was one of the harder integrals on this. All right. So number 10. This doesn't look like an inverse trig. We don't have perfect squares in the denominator, so don't try traveling down inverse trig. We can't factor anything. We could try splitting it up, where I have the integral of x over x minus 1 minus the integral of 2 over x minus 1. And we could do this one fairly easy with a natural log. But this guy over here, if I let u be the denominator x minus 1, du is just dx, and we still have that pesky x there. So, although breaking up sometimes helps us out, it doesn't actually get us much closer to our answer. So let's take a look at this one, letting our denominator be our u. So letting u equal x minus 1. Du is dx. But again, we haven't taken care of this up here. So we're going to need to do back substitution. We need to solve for x and substitute that back in. You could have done the same thing down here with this piece, where we solve for x and substitute that back in. But just doing that from the beginning. So if we let u equal x minus 1, du is dx. Again, I need to substitute in so that this is in terms of u as well. Now, over here you'll see, so we have x minus 1 equals u, but we need x minus 2. So making this x minus 2, subtract 1 from both sides, we get x minus 2 equals 1. You could have honestly just solved for x. If I were to do that, u plus 1 equals x. Do we agree? that this yields x equals u plus 1. Are we okay with that? So when I put this into my integral, x is u plus 1 minus 2 over x minus, whoops, over u. What does u plus 1 minus 2 simplify down to? U minus 1. And you'll notice that's what they got here. So you could have just solved for x and substituted in, or manipulated your equation to make it match up. Either way, so now we have the integral of u minus 1 over u. Where do we go? Okay, and now breaking it up, we have then u over u is 1, and negative 1 over u. So we have antiderivative u, antiderivative natural log of u. Again, if you were to break it up from the very beginning, like over here, you would have the same process you would go through, but it's advantageous to do it from the start. Don't forget your absolute values. They end up having absolute values in theirs. But don't forget your absolute value and your final answer. Questions with number 2. Definitely no word. Do you think they wanted to unpack this? Alright. While we're here, let's go ahead and take a peek at 12. Oh, yes. Let's take a look at 12. This was a good one that made you think about it a little differently. Alright, so number 12, it says if a definite integral is first approximated by using two inscribed rectangles, and then approximated using the trapezoidal rule, what's the difference between those approximations? Now, this is not a calculator problem. If you were to graph our function here, you would see it looks something like this. Okay, we are looking from 0 to 2. And they didn't tell us whether our rectangles are left hand or right hand. But they did tell us that they need to be inscribed. So we have to figure out which one gives us inscribed rectangles. So you needed to know what the function looked like to know which one would give you inscribed rectangles. What does inscribed mean again? It's completely under the curve, inside the circle. Yeah, that's the geometry one. So if I try doing my rectangles, and I need them to be completely under the curve, is my left hand or my right hand going to yield inscribed rectangles? Talk with your shoulder partner nearby you. Is left hand or right hand going to give me rectangles that are completely under the curve?
What did you say? Yeah, I agree. I was
Alright, if you think left, raise your left hand. If you think right, raise your right hand.
That's confusing.
It's confusing for me. It wasn't a good idea. Okay, I think I see most left hands. So left hand, we want some. Left hand means that I'm going to use the left endpoint for my height. Lo and behold, those both remain underneath. So it's my left hand Riemann sum, the left Riemann approximation method, that will give me inscribed rectangles. So you had to interpret inscribed for this particular situation as being left hand. Remember, it depends on whether our function is increasing or decreasing. But for this one, left hand. So you'll see our width is 1, and our height at 0 is e to 0, our height at 1 is e to 1. For trapezoidal, it's just normal trapezoidal. They told us that there are 2. So my trapezoid method, 1/2. My width is 1. That's my 1/2 and 1. And then my trapezoids look like this. So I need e at 0, e at 1. And then for my other trapezoid, I need e at 1 again. So that's why there are 2 of them. And then e at 2. And 2 squared is 4. And then you subtract. Okay, questions on that? Alright, let's go back to number 2. Alright, number 2. We've got exponentials happening. If I let u be the denominator, that's not going to help get rid of my negative 2x. If I let u be the numerator, that's not going to help get rid of my denominator there, so let's break it up. A lot of times, guys, consider that when you have adding, subtracting in your numerator. So I have e to the x squared over e to the x squared is just my 1. Then negative 2x over e to the x squared gives me this guy here. Alright, so this first piece is easy. Now the second piece is going to require a u sub. So just going back. Remember, our u's are often the inside piece, the inside function. So if I look at my inside function there, make sure its derivative is represented. The derivative would be negative 2x. So that's 2x dx. Don't lose your negative, though. Did we lose our negative? We lost our negative, didn't we? Don't lose your negative. Okay, so let's scratch this and do it on our own. So we have the integral of 1 dx. So this would be the integral of e to the u. And do we agree that our du is negative 2x dx? So we would need negative du equals 2x dx. Are we okay with that? Okay. So 2x dx is negative du. Okay, so now we can go ahead and do our antiderivative. Antiderivative 1 is just x. And then we have minus antiderivative e to the u is e to the u. Let's go and put our x back in. E to the negative x squared. Let's see. So we should have x minus, it should be b, not c. So b for that one. Questions with that? Those of you that did get this from, did we get b? Oh, good. Good. All right. So B is the correct answer for that. Okay. And then let's go ahead and go to 5. Yes. Because that's my inside function here. And if I let it be the inside, its derivative is represented. So when we do our du, it's going to take care of that piece. If I would have let u be just 2x, the derivative would have just been dx, and I would have still had an x within my function. So it was the only option for you that would take care of all the x's within my function. Well on it. Let me know if you're still stuck. All right, number 5. So it says,
good afternoon, pardon this interruption. Softball tryouts will begin outside at 3:30. If it starts to rain, then we'll be in the main gym. Any questions, please see Coach Anderson. Don't forget to come out and see Carpet Night and at Saturday, 7:30. Admission is $5 for students and $10 for everyone else. Students, remember to wear white tomorrow in recognition of the events in Florida last week. During lunch, bring a donation to help the victims' families. Leadership will have wings of love for you to share out your messages of positivity and appreciation. All students and staff are invited to participate. See you there. Thank you and have a great day.
alright guys, real quick, listen up. For number 5, they're asking for the derivative. We see an integral that has a variable. When we do our derivative, this is fundamental theorem of calculus, this gets substituted in. Cosine of 2x quantity squared times the derivative of that. So that's how we get 2 cosine of 4x squared. Then take your root pi and substitute that in.
Can we get Lady Galicia 1 to the office, please?
Lady Delicia Swan to the office, please. Thank you.
So guys, your homework review packet, make sure you're ready for the test. Go through your quiz, you should mess up, come see me with questions. Because, so my D is negative 4. I see. It was a mistake. You're right. Thank you. Yeah, you're right. Yes. Hold on. Because Josh just brought this to my attention, I want to make sure, because at least you're aware. For number 2. So it was 1 TX, but it was 9 TX. Yeah. So it was actually C. C is correct because it was, yeah, we have a minus there. Okay. Whew. Sorry. Okay, what was your question?